I know that I've mentioned before on this podcast that in order to have biofacts for my in-person interpretive nature programs, I do a lot of salvage, which is a really nice way of saying I pick up dead stuff, usually, but not always, roadkill. And as you might imagine, that can be smelly, both the picking up part and in the making it suitable to share with other people part. Now, admittedly, since I've been doing salvage, I've become a bit weird in that when I see or even smell something dead, I tend to investigate, just in case it's something interesting that would make a good addition to my collection of biofacts. So the other day I was out riding my bike and I stopped to investigate the unmistakable scent of decay. And moving a trash bag on the side of the road, I discovered burying beetles underneath. Burying beetles are a type of carrion beetle. Doing salvage, carrion beetles are a fairly common sight. I've seen several different species of carrion beetle before, but I think this was the first time I'd actually seen a burying beetle. I mean, it doesn't help that they're primarily nocturnal, but they're really fascinating insects. So today, I'm going to tell you about burying beetles. Not to be confused with burying beetles, because one is a species of carrion beetle, the other is just throwing dirt on top of insects. I'm your host, Tim the Nature Nerd O'Hara, and this is the Dispatches from the Forest podcast. Carrion beetles in general, and burying beetles more specifically, perform a really important service in the ecosystem. By burying and consuming dead animals, they aid in nutrient recycling, allowing nutrient-rich carcasses to be recycled by the ecosystem. But burying beetles are a little bit different than other carrion beetles. Most carrion beetles lay their eggs in raw flesh, particularly that of dead animals, and also fungi, which their larvae consume when they hatch. Incidentally, the larvae and adults also eat maggots and the larvae of other carrion beetles that are competing for the same food source. But burying beetles, they're called burying beetles because they bury the carcasses of small vertebrates like birds and rodents before they lay their eggs. Apparently, they also bury rancid meat from trash bags left on the side of the road. The point is that by burying this larval food source, they help keep it and their larvae safer from competitors. So, what's a burying beetle look like? Well, they're actually pretty easy to identify. First of all, they're a beetle. You probably have a pretty good idea what a beetle looks like. And these are fairly big, about 1 inch to 1.5 inches long, 25 to 38 millimeters. Second, they're black with a pair of distinctive scallop-shaped orange-red markings on their elytra. Third, burying beetles have large club-like antennae, the ends of which may also be orange. And finally, because those antennae are equipped with chemoreceptors capable of detecting a dead animal from a long ways away, they're probably under something dead and stinky. Now, if the carcass is small, like, say, a small bird or a mouse, something like that, the beetles will fight over it amongst themselves, males fighting males, females fighting females, until only one of each, usually the largest, remains.
Welcome to another edition of Thunderdome!
If a lone male finds a carcass, he waits for a partner to join him. Single males attract mates by releasing pheromones, but females, well, they can raise a brood alone, fertilizing their eggs with sperm stored from previous copulations. Gotta love a strong, independent woman who doesn't need a man, am I right? With a larger carcass, several pairs of beetles may cooperate and raise their broods communally. But whether solo or pairs or the proverbial village, the prospective parents start digging a hole up to 2 feet or 60 centimeters deep below the carcass. Also during this process, they cover the carcass with antibacterial and antifungal secretions, which slow down the decay and reduce the chances of the smell of rotting flesh attracting competition. Or weird guys looking for biofacts, I guess. Ideally, the carcass is rolled into a ball and the fur or feathers are stripped off and used to line and reinforce, and I'm not making this up, but it's called the crypt. But it's also called the nursery. Wait, that's not the same. Which is where it'll stay until it's completely consumed. This whole process takes about 8 hours, the burying part, not the consuming part. Now, like I mentioned, other types of carrion beetles lay their eggs in the raw flesh, but female burying beetles lay their eggs in the soil around the crypt. After a few days, the larvae hatch and move into a pit in the carcass created by their parents. Now, burying beetles are unusual among insects because both parents take care of the brood. Now, the larvae can feed themselves, feeding on that carcass that their parents worked so hard to bury, but they also beg their parents to feed them, like baby birds. So both parents also feed the larva by digesting the flesh of the carcass and regurgitating liquid food for the larva. The things we do for our kids. The technical term for this is progressive provisioning, which sounds a whole lot nicer than vomiting up rotting flesh. Progressive provisioning just means that they feed the larva from the time they hatch until they're completely developed, as opposed to mass provisioning where all of the larval food is provided before the egg is even laid. Progressive provisioning is fairly common in eusocial insects like bees, ants, and wasps. But in those insects, it's just the females, and a lot of times not even the mother, providing the food. Burying beetles are the only known example of progressive provisioning by a solitary insect, which means technically that they're considered subsocial. They don't associate with other adults, but they do provide care for their offspring. I'm really starting to relate to burying beetles here. Larvae take several days to mature, during which time the adults continue to protect their offspring. No easy task since there are a lot of competitors out there like flies, ants, or other burying beetles. On a side note, as a defense against carcass competitors, some burying beetle species carry phoretic mites that eat fly eggs. But lab experiments have shown that the mites sometimes eat the beetle's eggs too, so yeah, there's benefits, but there's also some risk involved in that strategy. But through the whole developmental process, which beginning to end lasts a couple of weeks, the parents fight off competitors, all the while maintaining an ideal nursery inside the carcass for their offspring. The final stage larvae migrate to the soil and pupate, transforming from larvae to fully formed adult beetles. As a parent of a child who is literally on their way to college as I write and record this, I'm feeling this. Protecting your kids, maintaining an ideal environment, and then watching them go off to transform into adults. I'm not emotional, you're emotional. Okay, Tim, pull it together. Now, before I relate too strongly to burying beetle parents, there is this little tidbit. Burying beetles are known to commit infanticide, also called culling their young at an early stage. So, yeah. To be fair, doing this ensures that the food provided by the carcass is enough to nourish all the larvae sufficiently. With the emphasis on getting the carcass buried and the eggs laid before the competition, this method of brood size regulation is probably a result of the eggs being laid before the female really has a chance to gauge the size of the carcass, and therefore how many larvae it can adequately support. If there's too many young, they'll all be underfed and develop more slowly, reducing their chances of surviving to adulthood. Too few young, though, means they'll be bigger as adults, but it also means the parents could have produced more of them. So the key is balance. The most successful beetle parents achieve a good balance between the size their offspring will be as adults and the number that they produce. This type of intentional cannibalism of offspring to manage for the carrying capacity of a limited resource is relatively uncommon among insects. Now, 15 of the world's 75 species of burying beetle can be found right here in Wyoming. And just when you thought they couldn't get any more interesting, because I know you were just thinking, wow, burying beetles couldn't possibly be more interesting. In the year 2000, it was discovered that one of these species has apparently undergone a shift from exploiting carcasses to parasitizing snake eggs. It's the only known case of an insect parasitoid using a vertebrate host. So just to be clear, a parasite and a parasitoid are very different. A parasite requires their host for every aspect of their existence. Even though over time they do harm the host by extracting nutrients, a parasite without a host would not be able to survive. A parasitoid needs a host to nourish their young, which is usually fatal to the host. But once the young mature, they're independent of the host. So anyways, normally entomologists studying burying beetles will use dead mice to bait traps. But one species of burying beetle, Necrophorus pustulatus, or simply N. pustulatus, never seemed attracted to this carrion. In addition, at least on carcasses in a laboratory setting, these beetles were able to produce very large broods, up to 190 large offspring, versus 30 to 45 for most other species of burying beetle. Now, like I mentioned earlier, usually a large brood size comes hand in hand with a decrease in individual offspring size, but not in this species. So the question became, why not? Theories ranged from that N. pustulatus used larger carcasses like rabbits without burying them to what's called interspecific brood parasitism, that it lays its eggs in the nests of other burying beetles, kind of like brown-headed cowbird does in the bird world. But in the year 2000, a paper in the journal Ecoscience by two snake biologists, Gabriel Bluen-Demers and Patrick Weatherhead, revealed something surprising. Now, they were studying the nesting ecology of black rat snakes in Canada by radio tracking adult females to their nesting sites. Their purpose was to document the use of communal nests by these snakes and to collect information on clutch size and juvenile survival. Because black rat snakes nest communally in this region, a nest can constitute over 100 eggs, even though each female only lays 11 to 15. But when they examined the nests, they discovered that many of them contained both adult and larval N. pustulatus burying beetles. In fact, in some nests, 100% of the eggs had been destroyed by the beetles and their larvae. And here's the important bit. The closest thing to parental care provided by a mother rat snake is choosing a safe site for her eggs to be laid. And research has shown that eggs laid in communal nests hatch earlier, grow larger in their first year, and the snakes from these nests even swim faster than those incubated with just their siblings. But the probability of a beetle infestation also increases with increasing nest size. It only takes one infected egg to spread the beetles to the entire nest. So this is why N. pustulatus has such large broods compared to other carrion beetles, because it can raise enormous numbers of larvae in a large snake nest. I mean, it's got everything a growing larva needs. It's full of nutritious eggs, and it's already hidden away in a place with ideal temperature and humidity. Now, this behavior raises some really interesting questions that we don't have answers to yet. Did N. pustulatus evolve this behavior by first exploiting snake eggs that failed to hatch? How do the beetles even find reptile eggs? Are communal nests easier for the beetles to find, or do they just prefer them because of the higher concentration of resources? And how has this parasitism by the beetle influenced rat snake evolution? And what are the risks to other species of snakes if, say, these beetles happen to end up in a place where the snakes didn't evolve alongside this type of parasitoid? Are there other species of burying beetle that also parasitize reptile eggs? And what about farther north in their range where the snakes tend to be viviparous, giving birth to live young instead of laying eggs? What does N. pustulatus use for rearing their young up there? Is it something else like turtle eggs, or do they just stick to small animal carcasses? Just saying, there's a lot of opportunities for further study. Man, if only I'd become an entomologist. From the beetle's perspective, by shifting hosts, it's arrived at a very successful reproductive strategy. Again, like I mentioned earlier, there's a lot of competition for carcasses, flies and ants and fungi and bacteria and other carrion beetles, not to mention scavenging vertebrates like vultures and skunks and raccoons. So This beetle has secured a fairly unique niche. Plus, not having to move or bury a carcass saves the parent beetles a lot of energy prior to laying their eggs. Experiments have shown that N. postulatus females oviposit rapidly in snake eggs, and that male beetles elevate their sex pheromone emission in response to snake eggs. Other beetles in the same genus don't exhibit these same responses. While N. postulatus will use mouse carcasses to rear their young in the lab, no one has ever found them doing it in the field. The entomologists who performed these lab tests also found that N. postulatus adjusted its fecundity, the number of eggs laid, to match the available mass of snake eggs. How cool is that? And with that, my feral friends, we're going to end this episode. If you want to support the podcast, go for it. Here's some ways to do that. Become a patron. Subscriptions start at just $5 a month, and with 3 paid months, you get some really sweet Dispatches from the Forest merch. Find all the details at patreon.com/dispatchesfromtheforest. You can donate through PayPal using my email address, dispatchesfromtheforest@gmail.com, which is also a great way to contact me if you have any questions, comments, or a request for a future episode. If you want to send a check, that's not a problem either. Email me and I'll let you know what my mailing address is. You can donate using the Cash App and the hashtag ForestNerd. Go check out the merch store at cafepress.com/shop/dispatchesfromtheforest. Click on products and find something you like. Finally, follow Dispatches from the Forest on Instagram, Facebook, TikTok, and YouTube. I'm your host, Tim the Nature Nerd O'Hara, reminding you to go outside and get dirty. The Dispatches from the Forest podcast is a production of Dispatches from the Forest and may not be used or rebroadcast whole or in part without express written permission.